Moving on to example 3, we're asked to find the resultant force of these two forces. So we know that there is a force of 3 newtons and a force of 7 newtons, and that they act at an angle of 40 degrees to one another. So we come up with this diagram you see in front of you. And we're asked to find the resultant force, which involves magnitude, but also direction. So we're going to have to do 2 pieces to this puzzle. So we start with this, and we know that the resultant vector is actually the addition of 2 vectors. Well, how do we add 2 vectors geometrically? We remember our parallelogram. So this 7 Newton vector that we see here is also right up above. And the 3 Newton vector that we have can also move over here, and we close a nice parallelogram. And what we have is the overall resultant vector as the long diagonal between the two of them there. That's not very straight, so I'm going to try that one again. There you go, that's a little better. So we call this blue vector the resultant. It's the addition of those 2 vectors. So what do we do now? Well, we're going to focus our eyes onto the obtuse triangle that we see here. So if you forget how to add geometric vectors, I suggest you go back to 6.1 and 6.2 of your notes to remember. So looking at this triangle, we know that that's 7 newtons. We're going to need this angle in here. And how do we get it? Well, we notice that there is a C pattern in front of us, and the 2 angles in the C pattern must add to 180. So we know that this angle here, alpha plus 40, needs to equal 180. So alpha for us here is going to be 140 degrees. So we'll just put that into our diagram. So we have a 140 degree angle there. And now we're going to use the cosine law. So we have the angle in front of us. We also have the length of the 2 sides, okay, that flank either side of the angle. So this is the classic cosine law, and this is going to get us the magnitude of the resultant. So I've filled it in here. Please be sure you're putting your magnitude brackets on the resultant, okay? The question is incorrect if you simply write it like this, okay? The vector squared itself does not equal the right side there. Only the magnitude of the vector does. We'll deal with direction in a second. So pause the video now, please, and see if you can come up with the answer that I'm about to show you. So pause now. All right, hopefully you got approximately 9.496 as your resultant length. Okay, so this is how many newtons that the force actually is. We don't yet know a direction. We'll deal with that coming up next. So for the direction, we can pick one of 2 things. It has to be in terms of something, and the only things we had at the start of this question that were actually locked in were the 7 Newton vector and the 3 Newton vector. So we have to, if you look at the diagram right now, we have to consider the direction of this resultant to either be this angle here in terms of, between the resultant and the 7 Newton vector, or we could choose to have, just let that disappear, we could choose to have the angle that's between the 3 Newton vector and the result. Those are your only 2 choices in this case, because those were the only 2 things that were there at the beginning of the question. So I'm going to choose the between the resultant and the 7 Newton vector. So I'm going to put a little purple alpha right in our diagram there. And this is the angle that we want. I'm also going to add into our diagram, just to help us, the number that we came up with for the result vector. So as we move on here, I'll try and keep the diagram on the screen. So we need this direction, this alpha that I labeled above. And what are we going to use to get it? Well, we're going to use the sine law. Because if you notice what we have the the resultant vector as well as the angle that's across from it. You'll notice that the 140 is also in the bottom left as well. So we have this resultant vector, and we have the 140 degrees that's across from it. So we have the resultant and the angle across from it. We have the 3, and we need the angle that's across from it. So this is the classic sine law. So what you see here is set up for this purple alpha that we have. And I'll ask you to pause the video now and try and compute for alpha on your own, please. So hopefully you came up with 11.7 degrees. So now we actually need to make a conclusion of the overall answer, and we need to say this carefully because this alpha, once again, you have to remember, was very specific to it is in the direction with the 7 Newton. Okay, it's with the 7 Newton force here. So we actually need to conclude that to be very specific. So what we'll say is the resultant force has a magnitude of approximately 9 newtons, and it is at an angle of about 12 degrees with the 7 Newton force. So you need to be very specific about your conclusion here, which vector you actually concluded it about. And I'll talk to you in